1000 views now, even more, 1100, and well, I want to thank you for that, so thanks. As you might have noticed, I didn't upload any videos for the last 2 weeks, and the reason for that is very simple. I was just too busy working on last minute projects that I really had to finish, and so I really didn't have time. I did record a lot of stuff, but I didn't have time to put it together into a sensible video. So the material that I shot will be used in later videos. But here is a new video, so here it is. In one of the last videos I was talking about PWM and how to generate PWM with software, and well, and also I was talking about, I was actually ranting a little bit on microchip, on the lack of hardware accelerated PWM pins, and I was looking in alternatives. For instance, there are like chips that can generate PWM, and you have to feed them serial data, and it will generate the PWM. But there is a downside to that approach. You still have to pulse the individual steps, so you have to you know, give a very fast pulse with the microcontroller to actually have the PWM running, and then also in the end of the period you have to latch it again and reset the counters, and so your microcontroller is still busy with all the, you know, with the PWM. And actually what you want to do is just do it hardware accelerated, and you know, not have your microcontroller busy with that stuff. So actually Michael, which is an intern that graduated here, I gave him the assignment to come up with a solution for that, and he did. What he did is actually quite amazing. Let me show you in detail a little bit. What this is an FPGA. Well, an FPGA is like programmable hardware. So once you've programmed it and you've flashed it, or whatever they call that, it's actually the hardware that you're changing. You're changing the way the transistors and flip-flops are arranged in the silicon, and that's the only thing it can do. And the beautiful thing about that is that it's all the processes, or most of the processes that are that the FPGA is executing, are running simultaneously. So there's not such a thing as you know, procedures that run from top to bottom. It's more like everything is happening at the same time, and that gives incredible speed and hardware acceleration. That's just amazing. So that's the plus side of FPGAs. This chip right here, it's an FPGA, and the cool thing about this board is I can send it serial data, which is actually here the white wire. Just one wire from my microcontroller to this one. This is just the power that is synced. And I can send it data, and it will, you know, PWM, 32 channels at the same time, very high frequency, like hundreds of kilohertz, 16 bits resolution, like really amazing, beautiful PWM. And I don't have to do anything for it in the microcontroller that I'm using. I can just send it through the serial data and fire and forget, and this FPGA will take care of the rest. Actually, we called it the FPWMGA, which is a little nice joke in the name. And I really like it. And there's one more thing that the unit can do. It cannot only generate the PWM signals, I can even send it envelopes. So I can send through the white wire here, I can send, for instance, fade in the next 2 seconds, then go to 4000, stay there for 3.8 seconds, then fade down to 100 over a time period of 5 seconds, and then repeat the whole cycle 16 times. This is just a little packet that I send. It's like 15 bytes or something like that. I just send it away, and that's it. I don't need to do anything with the microcontroller. I don't even need to give it pulses or whatever, clock signals, nothing, just that's it. And it can do 32 of those at the same time, and I love it. So I'm going to use this in one of the coming projects that I have, And I just want to thank Michael for doing this for me and congratulate him on graduation. Let's take a look at Michael himself, because he also explains it very briefly. So here's Michael himself.
Nou, dit is een envelope breakout bordje. Dit is bedoeld om aangestuurd te worden met een microcontroller via een UART-verbinding. En dan kunnen er 32 envelope outputs worden gegenereerd, waarmee dit soort fates kunnen worden gecreëerd. Daarmee kunnen we dan LED-verlichting aansturen, zodat we daar patronen en andere dingen mee kunnen doen.